Mars can look still in photographs, almost like a desert paused in time. Then the atmosphere starts moving dust, and the postcard becomes a system. The horizon fades, sunlight weakens, solar panels lose output. Fine particles settle on lenses, joints, seals, and radiators. A rover that was healthy yesterday may wake up under a film of powder. A habitat that looked clean in the design render now has to keep grit out of its air, filters, and crew lungs. Above that visible weather is another environment people cannot see directly. Radiation from space, moderated only partly by Mars's thin air. This is Path to Mars on the Quantum Files. Episode 4 is about dust storms and invisible weather, the quiet environmental forces that turn Mars from a destination into a workplace with rules. Martian dust is not beach sand. It is extremely fine, easily lifted, and good at clinging to surfaces. Because Mars is dry and cold, dust can build electrostatic behavior that makes it stick where engineers would rather it did not. It can coat solar panels and reduce power. It can scratch optics. It can work its way towards seals, bearings, connectors, and suit joints. Chemically, Martian soil includes compounds such as perchlorates in some locations, which adds another reason to keep outside material out of living spaces. Apollo taught astronauts that lunar dust was more than dirt. It was abrasive, persistent, and operationally annoying. Mars adds an atmosphere that can move dust around the planet and feed it into storms. That makes cleaning and contamination control part of exploration, not janitor work. The boring systems matter. Filters, brushes, suit ports, airflow patterns, protective covers, and procedures that stop a little grit from becoming a mission tax every day. Mars has local dust devils, regional storms, and in some years, dust events that grow until they affect much of the planet. These global storms are not hurricane winds in the Earth sense. The atmosphere is too thin to shove with the same force. The danger is not usually a crew being blown sideways like a movie scene. The danger is sunlight going missing, temperatures shifting, visibility dropping, and dust settling onto systems that need clean surfaces. NASA's Opportunity rover survived many years beyond its planned mission, but a major dust storm in 2018 blocked enough sunlight that the solar-powered rover eventually fell silent. That history is not a reason to panic. It is a design lesson. If a future base uses solar power, it needs storage, oversized arrays, cleaning methods, and operating plans for storm seasons. If it uses nuclear power, dust still affects radiators, mechanisms, and outdoor work. Weather on Mars is not background scenery. It manages the schedule whether the crew likes it or not. Storms also complicate navigation and psychology. A crew may know intellectually that the base is safe, while the windows show a brown world with the horizon erased. Rovers may need to pause because landmarks and solar margins are poor. Science teams may lose days waiting for the atmosphere to clear. A mature mission treats that as normal weather downtime, not failure. The thin atmosphere changes how wind matters. A strong Martian wind does not push like the same speed wind on Earth, but during landing, even small atmospheric uncertainty can affect a descending vehicle. Dust can hide rocks, reduce contrast for sensors, and change what a landing site looks like between orbital mapping and arrival. After touchdown, wind and dust become part of the routine. Every EVA or spacewalk on the surface becomes a contamination problem. A suit returns coated with material that should not drift freely through the habitat. Tools come back dusty. Rovers carry dust into maintenance areas. Airlocks have to separate outside from inside without wasting too much air or inviting grit into life support. Engineers study suit ports, where the suit stays mostly outside and the astronaut climbs in from the back, as one possible answer. Whatever the final design, The principle is clear. Mars' work will be planned around keeping the outside outside. Dust gets the pictures, but Mars weather includes other quiet stressors. Temperatures can swing widely between day and night. The air pressure is low and variable. Carbon dioxide can freeze at the poles and return to the atmosphere seasonally, changing the planet's weather engine. For hardware, this means seals shrink and expand. Lubricants face cold starts, batteries lose performance, and thermal control becomes a daily job. For people, the weather outside is never just uncomfortable. It is incompatible with unprotected life. Even a minor suit or habitat problem has to be considered against cold, low pressure, carbon dioxide atmosphere, and abrasive dust. Forecasting helps, and orbiters can watch large patterns, but local conditions still matter. A crew needs instruments near the base, rules for outdoor work, and enough schedule flexibility to let weather win sometimes. Exploration is not weakened by waiting out a bad day. It is strengthened by surviving enough good days to do the science. Weather data also becomes part of route planning. A traverse that looks safe in a calm week may be delayed if visibility, temperature, or power margins are trending the wrong way. Mars crews will learn to read forecasts the way sailors read sea state, not as background information, but as permission. Radiation is the invisible weather that follows the crew before, during, and after landing. Earth has a thick atmosphere and a global magnetic field that reduce exposure at the surface. Mars has a thin atmosphere and no Earth-like global magnetic shield. During the cruise between planets, crews are outside Earth's strongest protection for months. On the surface, Mars provides some shielding from the ground below and a little from the air above, but not enough to ignore the dose. Galactic cosmic rays create a steady background. Solar particle events can produce shorter, sharper risks. NASA and other agencies study shielding, storm shelters, mission duration, and career exposure limits because radiation risk is cumulative and medical. It does not always make dramatic footage. It asks harder questions about cancer risk, central nervous system effects, cardiovascular health, and uncertainty. A responsible Mars plan does not claim radiation is solved. It manages the risk with measured exposure, shelter design, and conservative operations. This is also why habitat layout matters. A small storm shelter with extra shielding may be enough for short solar particle events, while sleeping quarters or work areas can be placed where water, supplies, or regolith add protection. Radiation planning is not one wall. It is a habit of putting mass where it helps most. A serious Mars system assumes bad environmental days will happen. Power plans include storms. Mechanisms expect dust. Habitats include filters that can be changed, cleaned, or bypassed safely. Rovers have safe modes. Spacewalk plans include weather limits. Medical planning includes radiation monitoring. The culture has to reward stopping work before a problem becomes heroic. That may sound less exciting than constant adventure, but it is how long missions survive. The International Space Station taught crews to treat maintenance, checklists, and comm procedures as exploration tools. Mars will demand that mindset with fewer rescue options. Redundancy is not pessimism. It is optimism that has read the data. The goal is not to build a base that never has trouble. The goal is to build one that can absorb trouble, continue operating, and give crews time to solve problems without turning every dust event into an emergency. That also affects how missions communicate success to the public. A postponed spacewalk may look disappointing from Earth, but on Mars, it can be the professional choice. The culture has to value judgment over spectacle, because the planet will keep offering chances to mistake impatience for bravery. Dust, storms, cold, low pressure, and radiation all point toward the same next question. Where do people actually live on Mars? The answer cannot be only a shiny dome in a painting. A real habitat has to keep pressure in, dust out, heat managed, radiation reduced, and people healthy through months of work. The environment does not make Mars impossible. It makes the architecture honest. Next time, we build the home that has to last beyond the landing celebration. The shelter is where every environmental lesson becomes architecture. If the house can handle the weather, the crew can spend its attention on real exploration instead of constant recovery.